the second portion of single replacement reactions. So I don't know why it is, but it feels like your screen, Leo, is just freezing and then moving barely. We had this happen once before when we switched someone's computer and worked out fine, but I'm not sure. Like I see other people's screens.
You can't hear like you're saying.
Okay, hey, Caitlin, you seem to be moving perfectly. Can you try your computer? Just switch the computer with Caitlin and Leo. Can you just switch your computers? Leo, why don't you Leo mute yourself?
Yeah.
I'm seeing her without any delay. Going to Caitlin's right now.
Wait.
So yeah, Caitlin's is not lagging.
We can't hear from Leo, so we're going to use Caitlin.
Yeah, and Leo's is lagging anyway, so. Okay. So I'm glad we got that all recorded here. So we're having lag issues again.
Oh, do we need it? Yeah. Let me see if that is.
Okay, now you're on the speaker.
Okay. All right. So I'm going to try and do the best I can. You guys are lagging pretty hard on my end here, so hopefully you can still understand what I'm saying. Can you guys give me a thumbs up if you can at least hear me? Okay, everyone.
Wait. No,
okay. One of the things that we did last classroom is we actually had everyone just turn off their own laptops, and then we just put the speakers on my laptop on, and it tended to work. But whatever works is fine. So one of the things I want to do right now, and again, we have about 20 minutes here, is I want to show you something here, and I'm going to present back to myself here. So watch. This are the type of two reactions we've talked about so far. Two individual things forming a compound, and a compound breaking apart into two individual things. And then we had three different ways that we had decompositions that weren't normal. We had metal carbonates, metal hydroxides, and metal chlorates. And one of the things I need you to be aware of is this. If you have any of those three, they go from compound to individual things. But you can go the backwards way as well. So the opposite of a decomposition is a synthesis. So for example, can you write on the board here, Caitlin, I'm going to switch over to the board view. Did you guys see me right there, or was it broadcasting still on her?
Oh yeah.
Okay, you saw me? Okay, so on the board, can you write MO as high up as you can. As high up as you can. Emily, it's a two-person job, huh? MO plus H2O goes to MOH, and underline the M on both sides. Okay, so watch. If you were to flip that reaction over, wouldn't that just be a decomposition of a metal hydroxide?
Yeah.
So what I want to tell you is that on the second page, there's some weirdo syntheses, and all those weirdo syntheses are just the opposite of the weird decompositions that we did. So you want to star it on the top of the second page. So anytime you have a metal oxide plus water, it'll form metal hydroxide. Whoever just joined in, you need to mute. I think, Kenna, that's you, I'm believing. Yeah. So the same thing would work if I did this. Can you do MO plus CO2? Goes to MCO3. And again, in your mind's eye, can you just flip the MCO3 around, and isn't that exactly the same as the decomposition but flipped? Now, I want you to star the top one, the MO plus H2O, please. That's the only one that I think I'm giving you. So you just have to memorize that a metal oxide plus water will always form a metal hydroxide. Let me give you an example. Let's write this. Let's go sodium oxide plus water. Write the actual words, sodium oxide plus water. And an arrow. Okay, so if we see that, look at the actual word equation above, doesn't metal oxide plus water give us a metal hydroxide? And in this case, isn't our metal sodium? So our word equation on the other side is going to become sodium hydroxide. I don't know, Leo, I'm really appreciative of you, but I don't know if you want to be writing, having your writing right side by side by hers, because it does make yours look slightly not as good. Just saying. Now, if mine were there, you'd look tremendous. But and let's do the formulas here. That'd be Na2O plus H2O goes to NaOH. If you want to do the NaOH on the other side while she's doing this, Leo, you may as well get a jump start on this. Let's take advantage of this being a two-person job.
Oh.
Yeah, don't make it capital. Evidently, we have two arrows in this, or one very lonely arrow. One extremely long arrow. Oh, who says teamwork doesn't work? All right. So watch. That's still fine. We don't have a ton of time, so I want to make sure that we understand stuff.
Okay.
Okay. So that's not balanced. But if you put a 2 in front of the NaOH, I'm thinking that maybe you balance.
No.
Okay. Now, just know this. If you were to look at that, doesn't it look like a compound and a compound? And normally when we have two compounds, don't we do a double replacement? So in this case right here, you have to just realize that that's the opposite of the decomposition of a hydroxide. So that's why it works the way it does. Okay. Now, second thing, I want you to erase everything. We're going to go to single replacements. I need you all to pull out your activity series right now. And I'm gonna have you write this statement down at the very top, as far up as you can. And this is the general statement. Whenever we have a metal plus water or an acid, you must use the words on the side of the activity series. And I'm going to show you exactly what I mean by that. I'm going to screen share my screen, and let's go to this. So this is the activity series. Now, these are all the metals that are down the side. We don't worry about the halogens because they're not involved in this at all. See how there's words here on the right-hand side? And in each case, it tells you what you do if you're confronting a water and acid. Now, understand, these lines right here, they're like break up these groups, break up the metals into groups. So lithium to sodium, that's one group. Magnesium to cadmium is another group. Cobalt to lead is another group. Hydrogen to copper, etc. Now, what that means is that if I give you any of these seven with either water or an acid, it will replace the hydrogen in either the water or the acid. Look at the second group here. The only difference between group 1 and group 2 is that the second group can't react with water, it can only react with steam. Now, really quickly here, what's the difference between steam and water on a practical level? What's the only difference?
Steam is gaseous, water is liquid.
Brilliant. If you couldn't hear it on the tape, he said steam is a gas and water is a liquid, and that's true. Now, I in the previous class, someone said, well, one has more heat than the other one does. Well, do you understand that when something's hotter, it reacts more easily? So if you go down the activity series, things become less reactive. So it makes sense that if as you go down, it's going to require a little bit more to make things react. That's why it's the second group can react with steam only. But if you put the second group with water, there'd be no reaction. Let's do this as an example. Can you write calcium plus water? And then an arrow. Okay, the hardest part about this is to recognize first that this is a single replacement. And if you read the sentence up above, we have a single replacement whenever we take a metal. Can you put your finger on calcium, please, there? A metal plus water or an acid, that's going to be a single replacement reaction. So can you write SR on the left-hand side, in the margin? So now the question is, how does this react? And now I want to actually do the formulas first. So can you write Ca underneath plus HOH? Leave a little bit of space because I want to show you, or not. That's fine. Okay, put an arrow. Okay, can you read for me one of the two up front, Leo, perhaps? Can you read for me what it says if you put your finger on the activity series next to calcium in the group? What does it say?
Can react with water and acids, replacing hydrogen.
Replacing hydrogen. So can you do me a favor? Can you write a loopy arrow from underneath the Ca to the H? And can you have the H, a loopy arrow going like way the heck out off on the top? Out. Perfect. So what that means essentially is this. The Ca is going to react with OH minus. That means we're going to write a new ionic formula. So when we put them together, Ca is a 2, by itself it's just Ca, but when we put it together in a compound, it becomes Ca2+. So can you write on the other side CaOH in parentheses 2? Now, if you're wondering how I got that, can you put your finger on OH on the left-hand side, please, as part of the water? On the OH, right there, yeah. That OH, we can think of water, and the reason I wrote it like this, we can think of water as H plus and OH minus together. So if I were trying to put together an OH minus and a Ca2 plus, which is what Ca becomes when it becomes a compound, we're going to end up with CaOH in parentheses 2. And here's the one thing that students almost always forget, or if they're going to make a mistake, this is what they make a mistake with. That H gets kicked off. So we have to write plus hydrogen on the other side. But isn't hydrogen a diatomic molecule?
Yes, it is.
So we have to write it as H2. Now, if I look at that right now, is that balanced?
No.
No.
Nope. So since we don't have a ton of time, I'd put a 2 in front of the HOH.
2, that's 2.
No.
That's right. Yeah.
And we're balanced. Now, I did this first so you can see how it reacts, but we still have to write the word equation. So up top, wouldn't it be calcium hydroxide plus hydrogen?
Yes.
Yes.
Okay, let me give you another example. Let's try with, can you show me the activity series really quickly? Just put up the screen. Okay, let's do this. Okay, let's write magnesium on the board. Magnesium plus hydrochloric acid. And an arrow. All of a sudden, we've gotten real laggy again. Okay, so if you take a look at that, put your finger on magnesium, would you please? Okay, isn't that a metal reacting with an acid? Which by definition, we said is a single replacement reaction. So let's write SR in the margin. And whenever we have a metal reacting with either water or an acid, we have to use the words. So let's look at the activity series. And Audrey, can you help me out real quick? Can you tell me, or Leo, can you tell me what's written next to magnesium on the activity series?
Can react with steam and acids, replacing hydrogen.
So same deal, right? Except this time instead of water, we have an acid. Now let me write out what the formulas are. Magnesium is just Mg. And hydrochloric acid is HCl. Put an arrow next to that. Leo, read that last part of it again. Can react with what?
Steam and acids.
Oh, that was trippy. I don't know if you guys all heard that, but you kind of did this weird auto-tune thing. Expected Kanye to pop up on the screen. Oh, see what I did there? I used a pop culture reference. Students, I am finally there. All right, so if you take a look at this, we're going to do the same exact arrow that we did up above, because doesn't it say magnesium can replace hydrogen? Yeah. So we're going to put magnesium, the loopy arrow underneath to knock out the H and knock out the H. And then on the other side, we're just going to write MgCl2 plus H2. Does everyone see that we can do that because magnesium next to it says it can react with acids. Now, I would guess that you're probably going to have to do a little bit of a review on how to name acids, or else it's going to become a little more problematic for you. Is that balanced, by the way?
Yeah, I put a
Yes.
2.
I see it right now. That's perfect. Okay, let me try one more. Give me any metal from the second group, please.
Zinc.
Zinc.
Zinc, right? Let's go zinc plus. Let's do it on the upper, at the very top of the screen. That top right. Let's go zinc plus water. And an arrow. Okay. Again, whenever we have a metal plus a water and acid, we have to go to the periodic table. So can you everyone virtually put your finger on zinc? And Leo, will you read for me what it says next to zinc?
Can react with steam and acids replacing hydrogen.
So water is liquid, isn't it?
Yes.
Yes.
But it's
So
not-
will zinc be able to react with it?
No.
Nope. So we're going to write no Rickson on the right-hand side. Thank you, Adam. I'm guessing that was Adam.
Yes.
Or-
No reaction. Now, in order to get your full points on this, I would put SR on the left-hand side for single replacement, and you still have to actually write the formulas underneath because the reactants still sit there. So I'd still write Zn plus H2O or Zn plus HOH. Are you with me? So from here on out, and I think in your homework, you probably had a couple problems that had like a metal plus water, a metal plus an acid, and you're like, what do I do with this? This is what you do with them. The only thing that might be a little bit tricky, let's do one more. Let's have you guys do one more. Can you give me one of the metals in group 2 that is that has a Roman numeral?
Manganese.
Iron.
Iron. Okay, let's do iron. Let's go iron, and in parentheses put let's do Roman numeral 2, and then go plus water, and then put a little parentheses G and an arrow.
Ooh.
Okay. So if you put your finger on iron 2, obviously I just asked you to pick something from group 2. So we're in group 2. What does group 2 say again, Leo?
Can react with steam and acids replacing hydrogen.
You know what water with a G next to it means?
It's a gas.
The gas, which means it's a steam, right? So what we're going to do is we're going to write, just like we did before, because water as a gas or water as a liquid, the formula is still HOH. So can you write Fe underneath the iron 2 plus HOH? I'm only having you write HOH because it makes it easier to see. Now, the other thing I want to point out to you is this. Can you put your finger on the Roman numeral 2 for a second here, please, Audrey? Okay. The only reason I'm putting that Roman numeral there, because it's not an iron, it's not an Fe2 plus yet. But if I don't tell you what Roman numeral is, you won't know what Roman numeral to make it when you're putting the other side of the equation. So you see how I still write it as Fe, but then when it hooks up with the OH, because you guys realize it's going to take the place of the H plus, right? You're going to end up with Fe2 plus and OH minus. Can you put an arrow to the other side? And it's going to be Fe, OH in parentheses 2. Plus H2. That's one of the mistakes. Again, I said people forget to knock the H off. Is that balanced?
Put a 2 in front of
Feels
it.
like we probably have to put a 2 in front of the H2O. And then we write the name on the other side. Now we do have to keep the Roman numeral in. It's going to be iron 2 hydroxide plus hydrogen. Okay. Can you guys all hear me right now? Can I get a thumbs up? Okay. So thank you. That makes me laugh. So here's what you're gonna do, because I have to actually run to my surgeon. I'm going back there today, and hopefully they're going to. Yes, the Roman numeral can be different. That's why we have Roman numeral. So that's why I have to tell you that it's Roman numeral 2. In one of your homeworks, I think it's the second one or third, or maybe it's the fourth one. They just say copper nitrate, and that copper nitrate, when you get to it, should read copper 2 nitrate. Because if I don't tell you what the Roman numeral is, you don't know what the charge is. So any of the ones that are in the transition box, Maddie, by the way, her question was, can the Roman numeral ever change? Absolutely. And we have to tell you what the Roman numeral is. That's why I wrote iron and put parentheses 2 in it, even though it's a regular atom. So your homework is going to be this. You're going to do worksheets 4 through 8. And for the remainder of class, you're going to work on these things. But what you're going to do is this. At the very start here, you're going to grade the first 3 worksheets. Mr. Ambiel is going to give you the key for that. And then you can partner up, and I want you to do these. I want you to do the worksheets 4 through 8. Now, 2 things you should be aware of here. Next class period, I'm going to give you your first quiz on predicting reactions. And as much as you're going to hate this, it's exactly the same as the worksheets I'm giving you right now. Exactly. And I'm going to give you guys 15 minutes to do it. So what you might want to do as you are practicing on these worksheets 4 through 8 is you might just try doing one all the way through and time yourself, see whether or not you're within 15 minutes on it. Mr. Ambiel as well has the answer keys for all of these 4 through 8 as well. So I would suggest as you're doing them, maybe try doing one full worksheet straight through as if it's a quiz, and then check your work. And also, if you notice here on the calendar, you also have a test that's going to be next Friday. I think next Friday, because as of right now, with the fantastic help of Audrey and Leo, you had me doubting that the tag team could work, but you made me a believer. Maybe now from here on out, we'll have double all the time. Of course, with the assist on Caitlin's computer. Thank you for letting me borrow that. Oh, a pound. I like that. That's what young people do to be show affirmation. Well done. I'm learning your language. So I would absolutely make sure that you can do these know the templates. And here's the thing. Essentially, what these more are just ionic formula quizzes, but you have to know what the reaction templates are. So anyway, I've got to run to the surgeon right now. I'm going to have probably a tutorial session again tonight after I get back from the surgeon. Just check your emails. So if you have any questions about stuff, you can join me. I'm very grateful. Audrey, thank your mom again for us for the food last night. Her mom brought us food, and it was really, really wonderful because my poor wife has just been overloaded. So thank you very much, and thank you. Guys, I got a bolt, and I will see you guys later. Tutorials are not recorded. Tutorials are just literally you come in, Ellie, and you just sit in the chat room if you have questions. So it's not like I'm not doing a review. It's if you need help, just pop in, and even if you want to do like homework while I'm online, I'm just going to sit here with you. So I almost said love you guys because I'm so used to saying that to my wife, but I'm not going to say that because that's creepy. But I'm looking forward to hopefully being back with you next week. Say a prayer that things go well today at the surgeon. The tutorial, I think I'm going to do it tonight at 4:30, 4 or 4:30. Depends on when I get back from my surgeon. And by tutorial, it's, again, not me teaching you anything. It's me sitting here and listening to you if you have questions. And I got a bolt, so take care, guys.